Conway's Game of Life was created by British mathematician John Conway in the 1970s. It's a simulation of cell evolution with a set of very simple rules but really impressive results. Today, I'm gonna code it from scratch using just HTML, CSS, and JavaScript. I won't use any libraries or frameworks, just what comes bundled in any web browser. So, first thing I'm gonna do is open a terminal and we'll create a folder, and inside it I will initialize a Git repository so that I can track all my changes. And then let me open up VS Code. Let's see what we have here. Obviously it's empty, so I will go ahead and create an index.html file, and inside it we'll just use the basic template that I can trigger by writing an exclamation sign inside an HTML file in VS Code. So let's keep everything as default, and here I will change the title to Conway's Game of Life, and maybe I can add an H1 saying exactly the same, Conway's Game of Life. All right, let me open this, develop Conway. Here it is. So this is looking pretty bad, arguably. One way to make it look better with not a lot of effort is to use a CSS library or framework, maybe they call it framework, which is called Pico CSS. And here, if you go to get started, you can download it. And once you get it, you can extract it, and in the CSS folder you have to get, there are different options here, but let's start with the basic. Pico means CSS. This definitely does the job, and let's move it to develop Conway and paste it right here. All right, and let me do just one more thing. I will add this here for convenience. All right, so back to VS Code, we have this. And another important thing to mention is that they provide a starter HTML template that I'm going to use instead of the template that VS Code provides when you use that shortcut of the exclamation sign. I already pasted it here and replaced the title and the H1 with Conway's Game of Life. Now, if I reload the browser, it probably won't work because this is trying to get the CSS from the CSS folder, which doesn't exist, and I don't want to have it there, so I will just remove CSS from here, reload, and now it looks a little bit better. So that's it for the essential stuff. What I'm gonna do now is, wasn't this repo initialized? Okay, it's in it. There we go. And I will commit this. I can add something like a message like adds basic HTML with Pico CSS. Excellent. So we have the starter template and this is completely empty. So what should we do next? Well, The idea here is, or my idea here is to keep this as simple as possible. I don't want to jump into using any library or framework like React, Angular, or whatever. I just want to use vanilla JavaScript and use whatever is provided out of the box on any modern browser. So what I'm gonna do next is create like the grid of the game of life, and I will do that with set width and height. So we can do a grid that is maybe 20 by 20. And I will use a table, a good old table for doing that. So this should be something like this. So we have a table there, row, and a couple of cells that I will just start simple and have a couple of just a couple of cells here. Is this correct? If I save, this obviously looks with some refined styles. Maybe if I check out and find whatever we have in the tables, they have some basic formatting. So let's see if we can remove that formatting, or maybe it makes more sense to, instead of using a table, given that we're using Pico, maybe it's more sensible to just use divs, like nested divs, so that we avoid Pico from auto-formatting the table, and we can do whatever we like here. So just as a first idea, maybe we can have one div which is a table. Maybe we can call this section, which would be the section in which all the grid lies in, and we can have one div per row and one div inside per column. So for example, we could have something like this, and I imagine that now we won't see anything, but if I inspect this, probably we should be able to see the div here. Yeah, that's fine. I think I messed up here. Yes, let's remove that. All right. And if I reload, we have the body, the main, and the section here, and two divs with 5 divs inside each. There are many ways to make the markup here. You could use Flexbox, you could use CSS grid. I will just focus on setting a width and a height for these divs here. So let's add some styles, CSS for our own styles. So it should be like this. And just to check everything is working, we can do background color red. For example, if I reload, it works. Excellent. So what I want to do, in order to keep it simple, I will just select the section, any section. We have only one section now, so it doesn't matter. Later on, we can make the selectors more specific, but for the time being, let's just select the section, and let's let's select all the divs that are not the first level divs, not these divs here, but the divs that are nested inside another div. So we could do something like this: section div div. So this way I'm not gonna select the first level but the second one. And just to try that out, I could do, for example, width, let's say 20 pixels, height 20 pixels, and background color blue. And if I reload, there it is. There's something strange going on. Yes, the problem here is that we should make sure that all these divs are displayed in a single row. That can be fixed by telling the first div, section div, to be of display flex, and I guess that's it. Yes. So now we have one div here, which is one row, another div here that is another row. And maybe, well, let's keep it like that for now. Maybe it makes more sense to make the styles cleaner, to add some names here. So we could do ID grid, and this should be, it cannot be ID because we cannot use multiple times the same ID. So let's do class row, and here class row. I think that with this, it should be, we should have a better, actually we don't need this ID for the styles. So here we could do row, and here we can do something like this. So each div inside the row, or we can even add a class of cell, something like this, and replace all this with cell. Let's see. Okay, great, keeps on working. So we can add many other rows here, but I'm not sure I want to do this manually. I mean, we know this works already. If I keep on adding, oops, what did I break? VS Code is doing that, I don't understand why. All right, so if I reload, we can keep on adding cells and everything is fine. What I would like to do probably is add a gap, was like this gap, 2 pixels. No, I don't think so. CSS flexbox gap. Okay, I had a technical issue, and there was a part of how I solved the gap issue that was not recorded. So let me explain how I did it. So what I did was, first of all, make the grid be displayed as flex, and that made me have to add that the flex direction had to be column, because otherwise the default flex direction is row. So if I comment this out, what will happen is that all the divs that are inside the grid, which are the rows, they will come one next to the other. So to fix that, I do flex direction column, save, and there we go. And with that, I set the gap to 2 pixels, and this gap will determine the gap between the elements inside the right below the grid. So those are the rows. So the gap of the rows will be 2 pixels. And then inside each row, I also set the gap to 2 pixels, and this will determine the gap of the elements in right below the row. So those will be the cells. So again, we have a gap between rows of 2 pixels and a gap between cells of 2 pixels. If I don't know, for example, if I do 5 pixels here, the gap of the rows will increase, while the gap between cells will be unchanged. But let's leave it as 2 pixels. Another thing that I did that was not recorded was create a main JS script to, instead of generating the cells or hard coding the grid, being able to generate the grid automatically without having to write all the HTML. The generation function is not yet here, but I just added an alert hi to check that the page loads the script correctly. So it's showing the alert here. I want to generate the grid automatically. So what I can do is maybe let's write a function that's called generate grid. I think that's fine. I call it right away. Obviously, this is not gonna do anything at all. Maybe the grid should be a little bit bigger, 40 here, and maybe 4 pixels for the gap. I'll reload. Okay, I think that looks great. So what I wanna do now is generate I will probably stick with a square grid, but if we generate the grid automatically, we can play with the size pretty easily. So this function should create all the necessary markup automatically and add it to whatever we want. In this case, we could add it to the main element here. So the last thing I will want to do is probably get the main element, main el equals document query selector main. There we go, and main el append child, and well, we have to create something. What we can create is the first section here with the grid ID. So we have to create a grid el document create element section and grid el dot id. Is it like that? I guess, yeah. Grid. And let's split this up a little bit. Grid el. This is what probably gets much easier if you use React, for example. You can just write JSX and that's it. But I think it's not worth it at this point. So is it doing something? If I comment all this out, let's see. Do we have the grid element? Yes, we have it here. And it actually looks the same as it looked before. Excellent. Now, probably the next thing that we will want to do is, well, receive the width and the height in this function. once we have that, we want to, maybe let's do rows and calls here, and we will iterate over the rows first for let r equals 0, r lower than rows, r plus plus. And we know that for each row we will need a div that will contain that row as we have here. So we can just create that const row el equals document create element div, and we want the row el dot class name. I think this will work. I don't remember the API by heart, but let's try it out. Class name row, and here in the middle we will want to create the columns to do, but for the time being let's just grab the grid el and append child the row el, and let's see if this worked. So we have a section with the grid, and it seems that it didn't work because we're not telling the function how many rows and how many columns. Let's do 10 by 10 now. And now we have 10 rows. So then let's make a commit here. Actually, in order to keep things separate, we first change the size. So changes the size of the cell, and then generates rows. All right. Next, we want to create the columns. So here we can do for let c equal 0, c lower than calls c++, no pun intended, and let's just copy this bit and let's say call el create element div class name cell in this case. What else? We need to append that to the row, so to the current row. So row el dot append child call el. Excellent. And reload, make sure it works. Yeah, it definitely works. Actually, it looks nice. I will commit that, and by the way, I can now remove all this commented out code. Very important to remove commented out code. So now this looks much better. Generates the columns. Excellent. Now let's format this. Format document. I have to configure which formatter to use. So let's use prettier for HTML. Now I get a couple of small changes, and we can actually format this. Format document, configure prettier, great, and here format, save, and that's it. So formats everything with prettier. All right, so we have the code that generates the grid. We could potentially extract this for loop into a separate function, but I don't think this is big enough or cryptic enough to do it at the moment. So okay, so we've reached some sort of milestone. I still think that I will make this a bit bigger, maybe 12 by 12 at least. 12 by 12. Let's try 15 by 15. No, it started failing. It doesn't fit. So let's do 12 by 12, and I think it should look fine. Excellent. All right. Changes grid size. I think that we are ready to start playing with rendering maybe some state of the game. But for that, we need the state. Actually, we need to start thinking about how we are gonna represent the current state of the game. Something to clarify here is that now you will see that the grid is, let's say, in dark mode. That's because my computer is in dark mode now because of the time of day, and the Pico CSS library automatically changes colors based on dark mode or light mode, which is pretty cool. What we can do now is represent a particular state of the game with a matrix in code. And to do that, for example, we could do something like this. Let's say current state equals, will be an array of arrays. So I will initialize it with zeros. So in this case, it would be 12 zeros, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll probably strip out all these spaces so it's a little bit more compact. And we'll copy it 12 times. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. Okay, well, prettier formatted it like this, I'm fine with it. So let's say I just want to turn on a couple of cells. This is just to try it out. And I want to see if I can render this properly in the grid that I already generated. So let me swap this around, and maybe what we can do is create a new function that we can call render, render current state. And we expect this new function to obviously show in the grid whatever state we have here. So let's write it render. I will leave it empty for now and check that we don't have any errors anywhere. Okay, that's great. So I think there are many options. So maybe we can repurpose this generate grid method and use what we already wrote to render whatever we want to render. So let's do that. We want to remove the entire grid. So the first thing that we want to do is document query selector was grid, I guess, like that. Yes, grid. And how do you remove it? Remove, I don't remember. It's like that. Okay, so let's just try it out and see if it actually removes it. Okay, great, it removed it. That's fine. So the first step is there. I don't know what happens if it's not, if we weren't able to select it. So let me, okay, yeah, it was not there. So what we can do is use the optional chaining operator. So in case the grid is not found, we don't do anything. And because maybe when we render for the first time, we don't have a grid yet. But with this, we prevent the error of removing something that doesn't yet exist. And then if it exists, it will remove it without any issues. Obviously, if I remove this, if I comment this, the grid is still there. Okay, so next we have to do all this. We have to recreate the main element of the grid. We want to append it to the main element. That will happen at the end of the method. And in the middle, we will have these for loops, but instead of looping through the rows, we will have, actually we will be looping through the rows, but we won't receive the amount of rows, but instead we will receive this matrix over here. And the way to detect how many rows this metric has is to, if we receive the state, we can do state.length, because it's the length of the first array here. That's the amount of rows. And then with that, we will create a div, we will add the class row, that's fine. And then we have to iterate over the columns. So given this is a matrix, not a square matrix, sorry, but it has the same number of columns for every row. In order to see how many columns we have, we can do state sub0.length, because it doesn't matter which row we select, and then check how many columns that are inside. We can select the first one, the second one, doesn't matter, but we know that at least we will have one row, so that's why I choose 0 here. So this is the number of columns. Let me just do some cleaning here. Let's define number of rows equals state length. That's a little bit better. Number of rows. And then here, const number of columns. Actually, this can come here. State sub0.length. There we go. So this can be number of columns. All right. So we repeat this. And at this point, if we render this, we are not checking what's inside, but we should be seeing one cell for each element here. So if I save this and re-render, we have our current state. Well, not the current state, like the placeholder for rendering the current state. If I repeat this many times, we should not receive any errors, and we just see the last rendering of the state. So let's keep only one here. Let's remove this, and let's remove this. Should still be working. And let's commit this change. Repurposes create grid as render. Now, we probably want to highlight each of the cells that is on, and then keep unhighlighted the ones that are off, assuming that we represent on with 1 and off with 0. Okay, let's first turn them all on so that we can play with the style. So let's say call l.class list, I guess, equals, if I just leave it as cell, I guess everything stays the same. Yes, if I comment this, it disappears, that's fine. And let's add a second class that can be on, I guess, on, and reload. What's going on? On. What happened here? cell on. Am I doing this right? Let's check the documentation. Oh yes, no, it has a like different API. Class list. Okay, so add, and let's add a couple of things. All right, so dot add cell and on, right? Looks fine to me. Reload, there we go, and we have cell. That's excellent. Now, what do we mean by on? So here, cell dot on can be, maybe we want to highlight it in some shade of yellow. Let's try that out. I don't know how it will look in light mode, but let's try to just move the hue. Oh no, it won't do anything. Well, let's go to yellow first, and let's try to get here something like this. Okay. Let's move a little bit more to the left here, so that we make it a little bit paler. Okay, save. I think that's better now. Okay, but we don't want to keep everything on, so let's just do this. And now we want to check the current state. So if state at row at column equals 1, call element dot class list dot add on. That's it. And here we go. We have turned on the cells that were marked as 1. All right, so we can commit now, and renders the actual state. Excellent. Okay, so the next step is, I think, that one of the most interesting ones, which is evolve the current state into the next one. And for that, I will probably change the current state. To find something more interesting, we can go to Conway's Game of Life, to the Wikipedia article. Oh, by the way, this is really cool. All right, so if we go to Conway's Game of Life, we can find a couple of interesting patterns that evolve quite nicely. For example, this one, which starts out pretty simple. What is this? Okay, starts out pretty simple, and does a lot of crazy stuff. So let's create this. So it's 3, 1 to the left and 1 to the right. So let's turn everything to 0 to begin with, and then we need 3 guys here and 1 here and another one here. I think that's it, right? Okay, and if we re-render it, this is the pattern that we are looking for. Okay, now let's make it evolve. So for that we can use another function. Let's define how we want this function to look. And I'm thinking that maybe we want something like evolve current state, and maybe we can do new state, something like this, and we want to render the new state. Obviously, this will throw errors all over the place because, well, we don't have nothing, we don't have the function. So let's write that function. Function evolve, and we receive a state. And let's just for a second return the current state and render that, and we don't get any errors and we receive the same thing. That's great, that's like a safety check, but obviously we're returning the same thing here. So I think that we have to definitely iterate all over the place. So let's build that. Let's start by creating a result array, which will be empty. And the first thing I'm going to do, well, we know we will want to return that. And then we want these loops here, so I will grab this. We want to reuse that functionality. So we definitely want this type of structure in which we iterate all over the state array, the state matrix, sorry. And now we can do the following. For each row, we want to generate an empty row. So new row equals an empty row. That's great. And then here we want to push the new row to the result array. And then for each column inside the row, what we want to do is, well, here's where we have to apply the logic, but to begin with, let's just copy whatever we had on the original, again, to do a safety check and see that we are making progress in the correct direction, we are not breaking anything, etc. So we can push new row, push the current state. So state sub row sub column. That's it. So we iterate all over the rows, we create a new row, then we iterate all over the columns and push whatever we had in the original state to the new row. And when we finish iterating all over the columns of that row, we push the entire row to the result array. And to finish, we return the result. So this should show exactly the same thing as before. And it shows it. Excellent. Let's commit evolves by just copying the current state. So now the next step will be to change this logic so that we decide what is the new state based on what we had on the current state. And that's like the core of the game of life logic, which actually I think it's the nicest part because the rules are very simple. And as you've just seen, the things that appear with those simple rules that we're going to implement in a few minutes are really interesting. So let's keep on going. Okay, so now we have to show the next state based on the current one. So let's grab the rules. So here are the rules. Any live cell with fewer than 2 live neighbors dies as if by underpopulation. Any live cell with 2 or 3 live neighbors lives on to the next generation. Any live cell with more than 3 neighbors dies as if by overpopulation. Any dead cell with exactly 3 live neighbors becomes a live cell
as if by reproduction. All right. So we are iterating over all the cells here. Here we will have to calculate the new value. So maybe we can do something like new value for new cell value equals this. All right. And here, new cell value. Well, in order to keep this focused, maybe I want to create a function, separate function, calculate new cell value, and we will need the full state because we will need to look around the current cell. We have to look at all the neighbors, and we need to know which is the row, which is the column. And I think it should be enough with this. And then we, instead of doing this, we can do calculate new cell value. We have to pass the state, we have to pass the row, and we have to pass the column. With that, we can just focus on the logic of calculating the new cell value here. And we can even inline this, so we keep it nice and simple. All right. So basically, everything seems to depend on how many neighbors or how many live neighbors the current cell has. 2 or 3 live neighbors, more than 3 live neighbors, exactly 3 live neighbors. So I think that the first thing that we should do is calculate how many live neighbors the current cell has. Well, I will start with something like live neighbors equals 0, and then we can start checking the neighbors around. Maybe we can create 2 nested fors, something like for neighbor row equals row minus 1. So we want to go from row minus 1 to row plus 1. So neighbor row lower than or equal to row plus 1, neighbor row plus plus. And then we want to iterate from neighbor column equals column minus 1, neighbor column lower than or equal neighbor column plus 1, neighbor column plus plus. So this should iterate from the previous row, the current row, and the next row, and the same for the columns. Previous column, current column, and next column. Now, we have to check a couple of things. If we have to check that we are not out of bounds, because let's say we are in row 0 and column 0, neighbor row would be -1 and neighbor column would be -1. So we don't want to do anything there because we ran out of space, basically. So in that case, we probably want to check if neighbor row is lower than 0, we will just skip this iteration. We will just continue. I'm not gonna do return or break. We just want to continue, which skips to the next iteration of the for loop. Then there's another condition. If neighbor row is like greater than the last row, we also want to continue. If neighbor row is greater than, so that would be state.length, which is the size of the the total number of rows of our state matrix. Continue. And let me move this. If I keep this here, yeah, I think it doesn't make sense. I will just move this to here. I mean, if we are in a row that doesn't make sense to analyze, we can just skip the outer for loop. And also, I want to create two constants here. There was a name, yeah, number of rows and number of columns. I want to just grab this and define it here so my code is a little bit cleaner. So number of rows, I want to check this. If we have, let's say 10 rows, in this case, this should be number of rows -1, or we can do greater than or equal, because if we have, like, let's say we have 10 rows in total, the indexes for the rows will go from 0 to 9. So that's why I'm doing greater than or equal. And then, well, we have to create the same sort of condition here. If neighbor column is lower than 0, continue. And if neighbor column is greater than or equal to number of columns, we also want to continue. Okay. And there's another condition, which is if the neighbor row equals the current row and the neighbor column equals the current column, we also want to continue, because that's not a neighbor, that's the current row. So with that, we can now focus on the live neighbors. So if I reached this point here, then it means that none of these conditions were met. So that means we are on a neighbor cell. And in that case, we can just check if that neighbor is alive or if that neighbor is dead. So that's pretty simple. We have to just check if state at neighbor row, neighbor column equals 1, if it's alive, then what we're going to do is increment live neighbors. And that's it. So once these two for loops finish, we have to decide based on these rules whether or not the next value of the current cell should be dead or alive. So if the live neighbors is fewer than 2, so if live neighbors is fewer than 2, then this is pretty simple. Return 0. If live neighbors is 2 or 3, we can leave that for later. Any live cell with more than 3, we have to take into account the current value. So I was screwing up here. So if state at row and column, so the current value equals 1, that equals 1, that means that I'm in any of these 3 conditions. So then if live neighbors is fewer than 2, then return 0. If live neighbors is 2 or 3 equals 2, or live neighbors equals 3, return, well, lives on, it will be return 1, because well, it technically would be the same as the current state, but in this case, we already know it's 1, so we can just return 1. And then, if it has more than 3 live neighbors, if live neighbors is greater than 3, return 1. Great. We could rewrite this so that we don't have to use many ifs, but I want to keep it exactly the same as the rules are described here. And if, so here we cover everything, right? Less than 2, 2 or 3, or more than 3. Okay. And here, if it's dead, and also if live neighbors equals 3, exactly 3, then return 1. And if that's not the case, return 0. All right, maybe this one can be else. It's exactly the same, but I think it's a little bit easier to read. I think that should be it. So maybe we can run this again and see what happens. Let me check. We had render current state, new state, render new state. Well, let's see. I don't know if it's gonna work in one go, but well, at least it changed. So now we can come here and see next generation doesn't look like it's evolving correctly. Doesn't look like it's evolving correctly. So we will have to check what's going on. Let's comment this. So is this equal, exactly equal? Yes, it is. It is. So let's see what's going on. We are iterating all over the place. We are calculating the new cell value. We're passing the row and the column. All right. Calculating the live neighbors. If we are out of bounds, we skip. Same here. This looks right. If we are in the current one, we also skip. And if the state that the neighboring row columns is 1, we increment the live neighbors. That looks correct to me. Now, let's check out the rules. Any live cell with fewer than 2 live neighbors dies. So if the cell at the row at the column is alive, if it has less than 2, fewer than 2 live neighbors, dies. If it has 2 or 3, lives on, and if it has more than 3, dies, doesn't live, dies, as if by overpopulation. And if it's dead, and it has exactly 3, becomes alive, and otherwise stays dead. All right, let's check it out. So we are looking for this. It's like a C with a tail here. Yes, looks nice. So let's evolve it 2 times. I will just newer state, evolve, new state, newer state. And now what we're expecting is this nice looking thing. Let's see. Yes, exactly. I will just go one more because I want to triple check. Newest state. What we want to see is this thing. So it's the same as before, but fills up here and here. Excellent. All right, it looks like it's working. Now, probably we want to make it evolve automatically every, I don't know, quarter of a second or something like that.
Okay, so last step is making this evolve automatically. So I think this should be pretty simple. So this is the current state. Let me do something to begin with. Let's change this to let, and we can do something like this. Current state equals evolve current state, and we will repeat this a couple of times, and then we will render current state. This should look exactly the same as before. Excellent. So now it's just a matter of repeating this every certain amount of seconds. And the way to do that is the following. We can set an interval. Let's rename this to just state. Actually, I will do it like this, state, right. And here we render and we evolve, we render and we evolve, and so on. So we can wrap this in a function called main loop. This is something typical of simulations, video games. You have a main loop that executes over and over again, and you can execute that with certain frequency. So in this case, we could do set interval main loop, I don't know, 500 milliseconds probably, and that should be it. Let's see. There we go. Wow. Well, it stops there because our area is quite limited. Well, this basically completes the first version. Let me just commit this. Makes it evolve every 500 milliseconds. What I was thinking is that maybe I could make this a little bit bigger. Let's do something like this. So we have 1, 2, 3, 4, 5, and then we add the same here, and we add 1, 2, 3, 4, 5 to the top, and 1, 2, 3, 4, 5 to the bottom. And another thing that we'll need to do here is in styles, make this a little bit smaller, something like 20 pixels, and this 2 pixels, and this 2 pixels. Something that we could do here as an improvement is create a CSS variable and then use a CSS calculation to get these 20 pixels or 2 pixels, but that's something that can be done afterwards. So let's see. Reload. I think that this looks much better now. At least we'll give it some time
to show a bigger evolution. Okay, so I guess that's it, at least for our first iteration. But I don't want to finish without committing this first. Makes the grid bigger. And I want to create a list of, let's say, to do items. I want to add a list of possible improvements that we could add, just some ideas. So one was extracting the grid size to a CSS variable, extract grid size to a CSS variable, and use CSS calculations to get the gap and grid size. That's one. That's a technical improvement. Then regarding the game itself, another improvement could be to have an infinite grid. Use an infinite grid. This is pretty disruptive, I would say, because here we are using a matrix to represent the state, but if we want to have an infinite grid, probably a matrix won't be the best representation. Maybe it will be better to have a state which is just a list of coordinates that are turned on. Just to give an example, I'm thinking about something like, for example, an array. Let's do this. For example, const state infinite, and we could have an array of arrays, and each element could be a pair of coordinates. For example, let's say cell that is in row, I don't know, 10, 15, and then another one that is in row, I don't know, 1, 20, and this means that only these two cells are on. And then we could change the algorithm to use this representation of the state to calculate which is the next state. And with this way, we could have a state as big as we want without having to have a super big matrix that would be difficult to manipulate, difficult to hold in memory probably, and would make the application run pretty slow. So that's another option. A second thing that could be improved, in my opinion, would be rewrite with, for example, React plus TypeScript. That could be interesting. Could be React, could be any other framework, but my point here is, instead of having to manipulate the DOM manually, like using append child and so on, using something like React could allow us to use a template system that would make things probably more readable. And also using TypeScript, in my opinion, is something nice, which always helps, especially if your code starts to become bigger. And another interesting improvement could be to, instead of having like setting the initial state here, be able to turn on the cells manually, like clicking on the cells and then hitting a play button, something like this, like the same thing as here, and then you hit play and that's it. That could be definitely another improvement. And actually, as you can see, this shows you that this, now that we're here, has a pre-infinite grid. Yeah, that's the maximum zoom out. and it's quite good. And that's it. Yeah, I'm not sure if it's infinite or on the contrary, it's really big, but works really well. So be able to interactively set the initial state. Something else. Well, obviously there can be many, like potentially infinite new features, but I think those could provide a good set of improvements that could make this work better. Having said that, I think I'll leave it there. Let me know in the comments if you want me to do another video, like a part 2, uh, implementing any of these or something else you would like to see. Thank you very much. Subscribe if you're interested on watching more videos, and see you next time.